Okay, hello, BioWorld. Please subscribe, give a thumbs up. Please submit your comments below. I'm here to help. So let's get started with Chem review. Moving an electron closer to the nucleus. What's the difference between moving closer to the nucleus and away from the nucleus? If you go away from the nucleus, energy is going to go up. So moving closer to the nucleus, potential energy should decrease. Yep. Next one. Atoms that gain or lose an electron. What's it getting at? Moles? No. That's a distractor. Protomers? What is that? Neutrons? No, it's just a neutral particle. Gain, lose an electron. We got ions, right? Cool. Next. All right, moving an electron closer to the nucleus. Hey, we just did it. What does it do to potential energy? Decrease. Next. Association of water with a glass tube. What's it getting at? You know the properties of water? What does it do when it comes in contact with glass? Water between glass tube. Electronegativity? No, it's not talking about property of various atoms. Polarity? No. Sticky bonds? What is that? No, it's either adhesion or cohesion. Adhesion is interaction of water with glass. Cohesion would be water between water. So let's go for adhesion. Yep. Next. Electrons have potential energy related to, hey, that relates to something we just did. So, is it charge? No. Orbital? No. Mass? No, it's position, right? Position relative to the nucleus. Potential energy related to position. Any substance that has mass and occupies space. What's the definition? What's this a definition of? Electron? No. Molecule? No. Material looks pretty good, but that's not what it's getting at. You got to know that matter is the answer. Oil, good solvent for liquids? No, lipids. Because of what? Why is oil a good solvent for lipids? Liquidity? No. Specific heat? No. Density? No, these are all just nonsense. Molecular weight? Not really. It's the non-polarity, right? It's a non-polar substance, hydrophobic. Okay, atoms belong to the same element if they have the same... What is the defining feature of an atom that associates it with a certain element? Is it the structure, orbitals, function, atomic number, number of neutrons? What do you think? Same element should have the same atomic number, right? Yeah. Next. Positively charged particles. Is a neutron? No, those are neutral, right? Electrons? No, they're negative. Ions? Those could be positive or negative. Carbon? It's not charged at all, so everyone should know this, right? Protons. Next. Oil is a good solvent for lipids because of its, remember this one? Yeah, non-polarity. Next. Where an electron is most likely to be found. Where are the electrons? Think of the model of an atom. Is it found on the S channel? No, that's just nonsense. The atomic wire? No, nonsense again. P wave, what is that? Are electrons found in the nucleus? No. Orbitals, right? That's where the electrons are. All right, next. Which rule is most useful for understanding bonds? Any of these look familiar? Yeah, during the Chem review, we talk a lot about None of these. pH is related, yeah, to intro chem, but it's not getting at bonds really. It's the octet rule for bonds, right? 8 electrons in an energy level. Association of water with a glass tube. Remember, is it cohesion or adhesion? Remember, for think water, water. It's the adhesion is the interaction of water with another material. Okay, so it's adhesion. Adhesion. Next, negative log of this concentration is used to calculate the pH. How do you calculate pH? What's the definition of pH? Yeah, it's related to the concentration of, it's either hydroxide or hydrogen, right? You know? Yeah, hydrogen, definitely. Next, positively charged particles, we've done it. Protons, next. Keeps pH balance. Hey, this is a new one. You remember from the reading? What keeps the pH balanced? Which one of these? Yeah, buffers do that. They balance the pH. Next. Which rule is useful at understanding bonds? No. Octet, right? It's the octet rule. Review that one. It's important. Which is the molecular weight minus the number of neutrons? Yikes. Sounds like a math problem. Molecular weight minus the number of neutrons. Molecular weight is like sort of everything in the nucleus, right? So you got neutrons and protons in the nucleus. So if you take the neutrons out of the molecular weight, you're pretty much going to get, or the atomic weight, you're pretty much going to get what? The number of protons, which is that the valence number? No. Mass? No. Molecular weight? No. Atomic weight? No. It's the atomic number, right? That's the number of protons. Next. Number 20, atoms with 4 valence electrons most likely form which bond? I think what this is getting at, you got to think about this. What type of bonds do we learn about? Ionic bonds, covalent bonds, van der Waals interactions, you know. Something with 4 valence electrons. It's not going to be accepting 4 more electrons. It's not going to be donating its 4 electrons. It's going to be sharing, right, to get to that octet. So what's sharing? Is it ionic, xenic, hydrophobic, nonpolar? It's covalent, right? Yeah, something like carbon, covalent bonds. Atoms that differ only in the number of neutrons. What is that? If you just change the number of neutrons, you get a monomer? No. We're going to learn that later. Do you get a cofactor? No, it's not relevant. You get a transporter? Absolutely not. You get an isotope, right? That's what isotopes are. Next, neutral particles in the nucleus. Neutral particles in the nucleus? Neutrons. Next. Negative log of the concentration? Hydrogen. Next. Come on, atoms with 4 valence electrons? Covalent. You can do this. The same on Earth as in outer space. Yikes. Which one is it? This can be confusing. Temperature? Absolutely not. Gravitational force? Come on, no. CO2 level? No. It's either mass or weight. This can be confusing. Which one is it? Yeah, always remember just sort of like the matter, right? It doesn't really change. So it's the mass. It's the same. Weight has to do with the gravity. So mass. Next. All right. Atoms with 7 valence electrons are most likely to form what? Yeah, this just needs 1 more electron, right? So it's going to accept electron, become a cation. So it's what type of bond? You got 7 valence electrons, 7 electrons in the outer shell. It's ionic. Boom. Next. Positively charged particles. Proton. Next. Molecules are an emergent property of what? If you go down from molecule, what do you get? Or how about if you go up from molecule? Molecules form maybe polymers, macromolecules. You're going up. How about going down? Because what's below emerges to molecule, which we're interested in. Charges? No, charges don't give rise to molecules. Monomers? No, they don't give rise to molecules. Neutrons don't give rise to molecules. Macromolecules don't give rise to molecules unless you chop them up. It's atoms, right? Atoms emerge. They're emergent property of molecules. Oil, good solvent for lipids, remember? Boom. Next. Same. All right, you're mastering this. You guys are going to rock this quiz. Any substance that has mass and occupies space, mass occupies space, matter. Next. How many covalent bonds would an atom with 4 valence electrons form? Remember, you got 4 already. You need to get to 8, so 4 bonds, 4 covalent bonds to satisfy that octet rule. How many covalent bonds would an atom with 4 valence electrons form? We just did it. Boom. Next. CNN are good examples of, oh man, this looks hard. Are they isotopes? Do they differ in the number of neutrons? Only. Are they ions? No. Carbon and nitrogen are not ions. Are they isomers? No, that's a distractor. Are they aminos? No. They got their elements right. Next. Water is a good solvent for carbohydrates. Why? Why do sugars dissolve well in water? Is it because of the specific heat of water? No. Molecular weight of water? No. Water, yeah, it's a polar substance, so there can be hydrogen bonding. Get those sugars into solution. Atoms with 4 valence electrons. Hey, we've already done that. Next. Keeps pH balanced, you remember? Buffer, right? How many covalent electrons would an atom with 4 valence? Okay, this is getting easy. I think it's time to stop. What do you think? Losing an electron. Oh, this is new. When you lose an electron, what is it? Is it oxidation or is it reduction? When you lose an electron. Gaining an electron is reduction, right? Redox is the combination, Yeah, it's oxidation. Losing is oxidation. Next. Nuclei contain. This is interesting. Which one of these are found in a nucleus? Are ions found in the nucleus? Come on. The moles is a unit of measurement, basically. Isomers. This is not related. Right? Is it protomers or neutrons? This is a distractor. Read carefully. That does not say protons. It's neutrons. Right? Next. Extremely small particles that all matter is made of. Which ones are these? What makes up matter? Is it bonds? Sort of, but they're not extremely small particles. Do chemicals make up matter? What are the small particles? Are atoms particles? Or is it just protons? What do you think? Let's go with atoms. Yeah. Phew. Next. Moving an electron away from the nucleus. What happens? Remember when the electron goes away from the nucleus, does energy go up or down? It's like sort of going up the stairs of a slide. Your potential energy increases, right? Same electron goes away from the nucleus. Potential energy increases. Don't choose destroys. All right. Association of water with a glass cube. You should know that by now. What is it? Cohesion or adhesion? Yeah, adhesion. Next. Extremely small particles that all matter is made of. Atoms. Next. What is matter composed of? Do you remember? Yeah, atoms. All right. Should we do it? Okay. Negative log of this concentration is used to calculate the pH. You remember? Is it hydrogen or is it hydroxide? pH. The pH is the negative concentration of hydrogen. Let's go to 50. Elements in the same column of the periodic table differ in, same column. What differs? Is it the pH? Is it the charge? Is it the value? What is the value? Valence electrons? Same column. Yeah, this is getting at electric negativity, right? If you go up and down a column, and the electronegativity changes for each of those elements. What do you think? Yep, let's check. Yep, we're right. Next, 2 more, and we're done. Any substance that has mass and occupies space, remember? Matter. Next. Okay, atoms with 4 valence electrons most likely form which bond? Remember, is it ionic or is it covalent? All right, it's covalent. All right, you guys, so keep studying and study hard for the bio. Have fun.